Hi students, today we are going to start problems with two right angles. This is related to applications of trigonometry. Here in this problems you have to observe and understand with respect to two right angle triangles will be there. So problems with two right angle triangles. You'll see the diagram, then you will understand. Right angle triangles. Problems with two right angle triangles. So for example, if you consider, suppose you are observing the top of a palm tree. Suppose we take it as a palm tree here, and we are observing the palm tree by standing at a distance away from the palm tree. Here suppose it is the location A. From this point we are observing the top of the palm tree, so we have to observe at an angle of elevation, that you can take it as theta 1, and this is the ground line, straight line. So this is going to be some angle theta or theta 1, or if you take for example here directly a specific angle, it has 30 degrees. And if you move towards the palm tree, like this, and again we stand at a specific position, that is at B, and again we try to observe the top of the palm tree like this. Observe the top of the palm tree. Now the angle of elevation, obviously it is going to be more, because earlier when we were at point A, the angle of elevation is 30 degrees. Now when we move towards the palm tree, we have to raise our hand further to look at the top of the palm tree. Okay, because we are near to the palm tree or building, we have to raise more our head upwards. So the angle of elevation is going to increase as we move near to the palm tree. So earlier it was 30 degrees. When we moved closer to the palm tree, it became as 45 degrees. Okay, if we consider the height of the person also who are watching, as we done earlier video the problems, if we consider the height of the, so here this distance here which I have drawn, this is the height of the person who is watching the top of the palm tree, or in place of the palm tree they can give the electric pole or some building they are watching. Any example they can give in place of the palm tree. Okay, so here we can give the palm tree top as D coordinate, and this here where the foot of the person who is standing and watching, that we can take it as F, and the palm tree with respect to the height of the person we can take it as C, and the bottom of the palm tree we can take it as E. Okay, so here if you observe, we have two triangles. Which are those two triangles is, one is, and both are right angle triangle, BCD. BCD is a right angle triangle. Similarly we have another triangle that is nothing but ACD. So these are the two right angle triangles. Here we have, one is two right angled triangles. One is we have ACD, that is the bigger one, we have ACD, and another, this is triangle ACD, right angle triangle, another is nothing but BCD, triangle BCD. Okay, so these two are the right angle triangles which we have. And another, if you observe, even we have a rectangle here, rectangular shape. rectangular shape here we have, that is ACEF. So this is nothing but a rectangular shape here we have. Okay, so like this they can ask the problems where we are changing our position of observation from point A to point B, point A to point B. For example, if they give the distance which the person moved from A to B. Okay, initially he is at A and he is observing the top of the palm tree at an angle of observation of 30 degrees. He moved to the location B, and here the observation elevation angle is 45 degrees. So the distance between A and B here is, for example, in the example problem, you can take it as 11 meters he moved. So that also you have to write. So we start solving the problem here. So AB is 11 meters, that is the distance between the initial position A and after moving to the position B. Okay, that is the distance 11 meters. Now angles here we have angle CAD. Angle CAD, earlier also in the video I have told CAD means you can take this direction. CAD means this one, that is 30 degrees. CAD we are going to get it as 30 degrees. Okay, so that is angle CAD is nothing but angle A, and which is nothing but 30 degrees. Similarly, if you observe for this CBD, angle CBD, this will give angle CBD. So that is angle CBD is nothing but 45 degrees. Angle CBD is 45 degrees. Okay, so these two angles, and here we can consider height. This CD we can take it as H. Okay, CD we can take it as H, that is not complete height of the palm tree, it is CD which is above the person's height. Okay, so CD here we are going to take it as H, height of the palm tree. Okay, here total height of the palm tree is nothing but ED. Total height of the palm tree, it is nothing but ED. Okay, right. So height of the palm tree, you can write height of the palm tree is the length of the straight line ED. Length of the straight line ED. Right. And BC, that is the distance between the palm tree and the second location of B point. Suppose we take it as distance X. Okay, BC we are taking it as, we are assuming let BC is equal to X meters or centimeters, anything you can write here. Since they have given 11 meters, so this X also you have to take it as in meters. Okay, so BC is the distance from the palm tree to the second location B. Okay, now if you observe this triangle CBD or BCD, right angle triangle, we have BCD right angle triangle. I will separately we can draw that to have clear idea. Here we have this right angle triangle BCD, and the angle of elevation at B is nothing but 45 degrees. Okay, angle of elevation here it is 45 degrees. Now BC we are taking it as X, and CD which we have assumed it as H. Okay, now we can take tan of 45 degrees, specific angle 45 degrees, we can take it as tan 45 degrees. Tan ratio tan 45, it is nothing but opposite side length divided by adjacent side length. Opposite side length is nothing but CD divided by adjacent side length is BC. Okay, so this is nothing but tan 45 and we know that CD is, we have taken it as H, and BC here we have taken it as X meters. Okay, and we know that tan 45 value, tan 45, this you have to remember, tan 45 is nothing but equal to 1. This is very important ratio. Tan 45 is equal to 1. So if you replace LHS tan 45 with 1, 1 is equal to H by X. Now if you do the cross multiplication here, just bring this X on the left hand side, we get X equal to H. That means what we got finally here in this problem is the distance between the position B and the palm tree is equal to height above the person's height, that is H. Both are equal. Okay, right. Now another dimension here we are going to calculate is AC. Okay, AC, if you calculate, AC is equal to 11 plus X. AC is equal to 11 plus X here. Right, this we can take it as equation number 1, we can keep here. Next, another triangle, we have two triangles here. We have from triangle ADC, now we take triangle ADC. Another triangle we have triangle ADC. Here we have triangle it is top AD, and here we have C. This is right angle triangle, and this is initial position from where the person is observing the top of the palm tree. Initial position before he moved by 11 meters, it is angle of observation is 30 degrees. Okay, now DC, it is, we have, what we have taken is H only, but AC we have here, it is already we have taken it as 11 plus X. Okay, so now suppose if you take tan of the angle, because we know opposite side H we are considered as H and adjacent 11 plus X, so we have to take tan 30 only, which we need to calculate here mainly is height of the palm tree H. Final our goal is to calculate the height of the palm tree. So we need to take here tan ratio of specific angle 30 degrees, which is opposite side length H divided by adjacent side length 11 plus X. So we can write it as H by 11 plus X. Okay, and we know that tan 30 is 1 by root 3. This you have to remember, tan 30 is 1 by root 3, tan 60 is root 3. Okay, now we already got here that H is equal to X. H is equal to X we got. So that we are going to substitute here in place of X. We can substitute H. In place of X, you are going to substitute it as H. Or you can place in place of HX also. One and the same. Now you have to do the simplification to solve and find for the value of H. Okay. So you're going to do the cross multiplication here. Simplify this and do the cross multiplication. So H, we take this 11 plus H on the left hand side. So 11 plus H and root 3 already it is there, is equal to H we get. Okay, now we can write it as H is equal to 11 by root 3, that is root 3 we are separately writing for 11 as well as H. So 11 by root 3 plus H by root 3. Our aim here is to find what is H. So now we can bring this H by root 3 on the left hand side. So H already there on the left hand side, minus H by root 3 we have is equal to 11 by root 3. Now we can LHS, we have H minus H by root 3, we can take the LCM, it as root 3. Okay, root 3 is the LCM, and H by 1 we have root 3 by 1 is root 3 into H we have minus, for the second one this is root 3 divided by root 3, it is going to be 1 into H, we get it as H is equal to 11 by root 3 here we have, this root 3 in the denominator of right hand side, in the denominator of left hand side will get cancelled, and in the numerator we have numerator of left hand side we have root 3h minus h is equal to 11, and from LHS we can take h common, so we get root 3 minus 1 is equal to 11. So here we get height, we have CD is equal to h is equal to 11 by root 3 minus 1 meters, root 3 minus 1 meters. And one thing here you have to remember that we should not keep square root in the denominator, so you can try to simplify this, or you can stop here. It depends on how many number of marks they have asked. If you have sufficient time, so even you can simplify this by multiplying numerator and denominator with root 3 plus 1, root 3 plus 1 rationalizing, so that square root in the denominator will vanish. Or you can keep here it as 11 by root 3 minus 1 also. So 11 into root 3 plus 1, if you have time to solve in the exam, then only you have to do, otherwise you can leave it as 11 by root 3 minus 1 only. Now in the denominator we have root 3 minus 1 into root 3 plus 1, that is a plus b into a minus b. So we can take it as a square minus b square. So we get 11 into root 3 plus 1 divided by this square, and square root will get cancelled. We get it as 3 minus 1, that is 2. So final answer we get is 11 by 2 into root 3 plus 1. Okay, so this is the problem where they have asked 2 by giving two right angle triangles. So what they have asked to find is the height of the palm tree. Okay, we'll stop here. Please share and subscribe. Further we will solve in next class.